Hello YouTube, good morning, and today this video is about an utility called the SCEMI library. The SCEMI is an interface specification from Accelera. So this is used generally on the emulator to simulation interface. It's not used any other place that as I know of. And in our company we had requirement to use it, so I came up with this implementation. And then the idea was reused, and the implementation got implemented in a different way. Um, um, but given that this is a full implementation of the schema interface, and it is so I'm releasing it on the open source. So you can find in my GitHub page the schema lib. Okay, so I have implemented the function-based interface. So if you go through if you go to the spec, you would find three types of interfaces. Majorly the function-based interface I have implemented, and then so I can't give a big reference to all the routines that I have implemented. So the source code is available for you to look into. What I would do here in this video is to actually give you a sense of what this is and what this can do, right? Run a simple test for you, right? This library can be used to send and receive transactions between or two simulations. Actually, not more, but two simulations, I suppose. And they can be running on the same host or on different hosts. So this is a particularly useful feature in case you have some issue that lets you not to build the complete design in one uh, executable, right? So, for example, we had a test bench that was created with the mind that it will be, you know, built only once. So when we had an requirement that the test bench has to instantiate two different designs with different parameters, the test bench was not scaling up, right? We are not, so there's so many if gaps, and the parameters passed, so that it was not able to instantiate the same design with two different parameters, and the test bench also adapting to that change, right? So it was not possible. So we use this solution to actually run two different instances of the test bench with the design with two different configurations, but communicating the transactions being communicated through the schema interface, right? Yeah, and other places where it could be used are like if your design is very large and you want to partition with multiple simulations, so it's also possible. That's one another possibility, right? So let's get started with it. So let's clone it. So schema lib, very less source file, so it should finish very fast. So you would see that the library is in the schema directory, and you have both the test bench and that interfaces to it, and you never need to look into these functions if, unless you are deep into um, fixing something inside it, or really want to understand about it, right? But otherwise, if you look into the schema function-based interface, all that you need to do is look at the documentation, and everything should be included for you. So let's see how to run a test. So the test directory, you have the run.sh. So that's that contains all the run commands. If you look into it, it actually it does two things. It builds two different executables, two VCS commands, right? And then it creates Unix named FIFO to uh, facilitate the communication between these two devices. So both the executables are started in parallel. If you see the ampersand that puts them into the background. The wait command lets both of them complete and then it comes out. Uh, yeah, so once it's completed and the run is complete, right? And then so the log files created are in so you have the dot.log and then the tb.log. So those are created. Those are the outputs. Let's see what is the test code, right? So here the testnet what it does is it basically references a particular reference a particular ins what is it? Yep, pointed to the other simulation and SVC outbox. So this is something that I have implemented. It's not part of the specification. So it's just like it's a class which can accept the any complicated data type and it can send that message. So in this case, it's actually taking a 30-bit data type and it's sending the message to the other side. And you see that I'm actually initialize the uh, data that needs to be transmitted and then keep on incrementing and then doing the loop for 10 times. So you should see that A0 to A1, A2, A3 up to A9 getting transferred to the other side to the DAT. And in fact, uh, this is the instance path that relates to where that relates to the receiver, right? So if you see the dat.sv, this is the SCEMI message import macro, which is actually an instance, and this is where the data is targeted towards. And here's also like the port with the 30 bits, and the invalid if it is high, it tells that the in data is valid, and we check for that at every clock edge. And if there is a valid transaction, we print what we obtained, and then we finish after like probably after we get 10 input transactions, which seems correct, right? We are sending 10. In real use cases, you would have multiple, such connections, and you would use such connections for, uh, you know, uh, synchronizing both the ends, both of the solutions. But in this case, this is just a demonstration. I just connected one port, just when just sending to it, right? So let's actually run it. So run it to run.message, and then the first executable should get created. The second executable is getting created. Both are done, both are run, and everything's finished, and you have the log files. So you have the executables and you have that log. What we are interested in is the dot log, whether did it receive anything, right? You can see that, yeah, as we expected, we are receiving data from A0 to A9. So that confirms that the transactions are happening between both the simulations, right? And yeah, this is implemented in PLI and VPI. So if you have an industry standard compiler that's implementing PLI and VPI, you should be able to compile the source code, right? So I already talked about the use case of the SCEMI lib. Again, I want to refresh on that. So basically, you can use it to maybe partition your build, because like your build is very huge that may not fit into one big machine. So we may want to use such kind of libraries to partition. Other one is if you're doing multi-die, right? Multi-die, when you're doing complicated topologies, so you may want to partition such kind of libraries. Um, one was a scenario which is again used in my company, in my workplace is basically we had a complicated test bench which we couldn't easily uh, use it to instantiate two different versions of the DUT. So what we used was we built the same design with different configurations of the test bench, two different executables, and use the SCEMI lib to communicate between both the executables. Right. With that, yeah, happy that I'm able to share with you this particular library in open source, and I hope it would help you. Let me know if I can support you in any way possible. Yeah, so that's it. So have a happy day. Bye bye.